Okay, hello everyone. We're going to start the session, and this is a discussion panel. So as Emma just told me, this is a true workshop spirit. We're just going to have a conversation, a discussion about, actually I can read the title that we selected, Building Long-Term Strategies for Ground-Based Instrumentation in Heliophysics. Of course, that's a very challenging discussion right now, but we have invited 7 speakers, 6 of them, they're here in the panel, so I'm going to invite them. Emma Spanswick from the University of Calgary, giving us the international perspective since she's up here. Mike Ruhonomi from Virginia Tech, he's representing SuperDARN, and also Bill Bristow from Penn State, also representing SuperDARN. Carlos Martinez from Boston University, representing several ground-based instruments from Boston University. Phil Erickson from MIT High-Stack, and Phil doesn't need any introduction or explanation. Mark Kunde from the University of Alaska Fairbanks, also representing several instruments in the neutral wing. And Danny Scipion from the Jicamarca Radio Observatory, also giving us a bit of the international perspective. Thank you. We also have a last participant, that is Bob Robinson from Catholic University of America and NASA Goddard. So, do we have enough chairs? Yes.
Do I need to scoot?
So to give you a little bit of perspective, the idea was to talk about long-term funding for the instrumentations that we have in the heliophysics field. And of course, this was planned months ahead before we could see any of the PBR, any of the budget requests, and we didn't know anything about the cuts. So the idea was to also have some of the program officers in the room. Personally, I didn't feel that that would be very kind to them, especially because there is so much uncertainty. And I personally didn't want to put any of the program officers on the spot. So because Bob Robinson has so much experience working with NSF, Bob has been very influential in some of the work that we have been doing. So the motivation for this comes from something that you might not have seen before. So with the GDC mission, we have something that is called the ground-based coordination, and I have been leading that effort. And there were 2 teams. The one that you probably have seen is the community team, and the idea for that was a 2-way communication. We wanted to inform the community what the GDC mission wanted to do, but we also wanted to see what we could do together to amplify the science outcome that we could have. And that coordination couldn't be something that just happens casually. We needed to plan ahead, years in advance, and for the ground-based instrument to be equal partners in this equation. And the other part of the team was an internal team, and those were members of the internal science team, all the instruments, and all the interdisciplinary science teams. And we were talking about many different things. One of the things that we did is we did a parallel STM, where we were analyzing what type of science and what more science we could do if we partner with the ground-based instruments. So, and then we switch gears and start talking about what's the strategy that needs to be put in place for this coordination to be something that continues in time, and for us to make sure that some of the instrumentation that we need is in place for the different missions in the future. So that's where this comes from. These are some bullet points from Bob Robinson and some of the questions and discussion points that we might go back and forth during the discussion. The first one is international collaboration. Of course, there are excellent examples. SuperDARN, the Chinese Meridian program is one of them, of course. How we can leverage the private sector, and there are several examples. Bob is very familiar with AMPER, of course. Citizen scientists and crowdsourcing, how we can obtain data and information from them, and how we do that in a more coordinated effort. Many of us just go online and try to find the observations that are the ones that we need. But how can we do that in a more strategic way? We also have I like this word, piggyback on existing sensor networks. So how do we do that? Take advantage of the phone technologies. We have cameras. The technology that we have in our pocket is advancing so quickly. How do we take advantage of that? Exploit existing systems. And we have way more, but I'll go to the next slide afterwards. So let's start with a question for the panelists. If this question is too difficult, let me know. Given the current funding situation, today we heard that, for example, MIT HISTAC has a 5-year funding, which is excellent for the incoherent scatter radar. But I'm concerned that, Phil, do you think that the agencies are going to have sufficient funding in the next years to maintain that funding level?
Okay, so it is very true that we got reviewed, thanks to Larissa, wherever she is, right over there, and received an award for the next 5 years of Millstone beginning in May 1st. We have only been obligated 1 year of funding. After spring of next year, I do not know what the landscape looks like because of the various, there's the award and then there's the obligation. And as anybody in here who has been PI knows that, you know, the agency tries to manage its current and forward commitments as much as it can. And this is the mortgage that you've heard people refer to quite a bit. And so for a larger facility, you know, it's much more difficult to front load that because of all the other things that have to be done, especially in the time we have now. So at the moment, yeah, we have a horizon of about a year, but on the other hand, as anybody, again, in this room probably knows, a few months from now, it's very foggy to me, and I don't really, so I'm not sure that I would take that as a concrete problem. It's just the fact of where we are for that particular facility at the moment. You may have also heard this morning that NSF is in the process of reorganizing itself, and it is unclear where all of the major facilities are going to land within the particular portfolio we have right now. So there is a bit of also some more information that has to happen before we know that. Other facilities are in different straits in terms of just the way that their awards are timing out. And, you know, like Superdarn has another set of dates. The A-misers do, goes on and on. So there are individual cases of this general problem of continuity. That's what I would say.
Okay, I'll follow that by saying that Superdarn is in a tougher situation at the moment. The U.S. Superdarn collaborators are basically living on no-cost extensions from the previous award and are waiting to hear the outcome of the discussions, I guess, that are going on about renewing that award. But we have been told that we're going to be cut and basically funded at a maintenance and operations level.
Anybody else have anything they want to add to that one?
Carlos, what's the situation with your instruments?
Well, for Jicamarca, we have an award from NSF. We are on the 3rd year. It's a 5-year award, so we still have 2 more years. And what I hope is that, as Phil was saying, it's a little cloudy in the future for the next few months. I'm hoping that in the next year and a half, or the next year when we have to write the next proposal, everything will be more clear and we continue operations. That's what I'm hoping.
I can just add, I'm actually not directly involved in the Pfizer grant, but it's either the renewal proposal has either been submitted or is about to be submitted, so Pfizer also is facing similar uncertainties. So I'm not directly involved in that, so I can't say any more than that, but I know that they're in the process of transitioning to their next award cycle.
Right. Yeah, that was my understanding as well. It's you know, the timing is very recent for that. Yeah. Anything to say? No?
from the view All-Sky Image Network, we're not part of the facilities. There is a grant, an aeronomy grant that is going through the last year, and we have not received the last year increment yet. And so, as everyone is saying here, it's very foggy. If anything, we operate 14 instruments worldwide, and the foreseeable future is like when there are issues, I don't know if we will be able to remediate or solve those problems. So if anything, as situation stands right now, it will be the downsizing of those 14 instruments. That's no idea, but we are going through this tough situation.
Yeah, this information is key because we all operate with the idea of these instruments are going to be there forever. But it takes a lot of effort to maintain, to deploy, to keep the data going, and I think that's something important to communicate to the community. We all get very happy when we get I always say our paws in the data and start playing with the data, but we have to acknowledge all the work that is behind in producing those data sets. Let me ask you, and I'm asking a lot of questions here, but we have a microphone down there. So if you have a question, please raise your hand. And Fumi, if you can pick up the microphone there. So Fumi is a student that is helping us in the session, so thank you so much. She's a graduate student from Catholic University of America. So please ask the questions, don't let me ask all the hard questions here. But in the meantime, today we also heard that maybe reformulating the way we request funding and making it a national priority. When I think about national priority and I think about defense, radars are one of the key things. Is there a way that we could reformulate the way we request the funding, but also get to do the science that we want to do nonetheless? And this is a question for everyone here, from the international perspective to the national perspective.
Is that a hint that
Yes.
I should start? Okay. So we've been facing this type of reformulation in Canada for quite some time. There's been some pressure to move us off the value proposition of pure discovery-based science. And we've seen that pressure for quite some time coming from our federal government. In recent years, and actually just 2 weeks ago, I was informed that the national agencies now, they want to see the term dual use in all of our applications. Like this is the term. So, and our applications are going to need to address dual use, and they're going to need to address economic impact. And so it's because it's been ingrained in us for quite some time. I mean, even our expansion, most people are aware of the expansion of the Canadian network that's coming, that we leverage the opportunity of GDC into what we call GDC ground. So we're, over the next 4 years, revamping the Canadian ground-based. It's a $15 million investment in getting new camera networks, rheometer coupled to GNSS, magnetometers, spectrographs, Fabry-Perot. So there's quite the expansion going on. And the selling point or the value proposition for that program, when we put it into the Canada Foundation for Innovation, was a line right down the middle. And it was 50% of the value proposition was discovery-based science, and 50% was strategic opportunities for Canada. Sovereign capacity in some of these applications, for defense applications, industrial engagement, development of dual-use technologies, development of a national test bed for space technologies, these types of arguments that are now ingrained in us. And so we've been living, I think, in this land for quite some time because our government, I think with less resources available to it, obviously is looking for more from that value proposition. So I feel like we have some experience that maybe we could help and collaborate specifically with the U.S. community on that as we move forward. But yeah, that's the landscape we've been living in terms of long-term sustainability will require a multi-user base for the instrumentation, and that allows for a more diverse funding agency approach. So no one funding agency is responsible for anything now. We've been solidly into this matching program for quite some time, where the Canadian Space Agency will take a certain element of it, but they're expecting both the institutions, the academic institutions, to fork out some money, and then matching funds to come from elsewhere, be they the defense program or industrial engagement. So, Phil?
And it's good to hear you've got some experience in doing that. I can say that for a couple things I've been involved in, it's like anything else. You have to know the community that you're also want to use that, and also understand how they deal with data and where their sort of sensitive points are. I'll give you an example. A while ago in New England, one of the electric grid people showed up and basically said, well, we're supposed to pay attention to these space weather events, right? And so I started talking to them about what was available, right? Okay, you can go here, you can look at this. And they stopped me and they said, you don't understand, our networks are closed systems. We cannot go on the web and download DST. We actually have to buy it from a broker who is certified to not mess up our internal network. And then I said, oh, and then the conversation changed. So in some sense, if one can be clever enough to provide, it's like a NASA level 3 derived data product that gets to what they want. And then furthermore, for certain communities, is just read-only, where you're not asking for anything out. You're just saying, here it is, go in. We don't know what you're going to do with it, but it's useful to you. That's, I think, a strategy we all have to learn, if you will, in some sense. So, that kind of thing is helpful.
I can respond to some of that.
Turn it on.
Is it? It's on. We're on. I'm good. So you are absolutely correct. So you can't just say you're dual use and go download my data and do something with it. And I would say a lot of the effort that we've gone through in Calgary has been now approaching our ground-based systems and the data products from a multidisciplinary standpoint. So the engagement for us, particularly of geomatics engineering, and Susan Scone on that side, right, that provides that critical link. She worked in safety critical systems, so there was a natural endpoint to connect to where we had that, where she was developing her own program that was utilizing our sensor data. And so we ended up having this wonderful collaboration where we're all a team, and there's the discovery-based stuff going on, right? The stuff that we do that you'll see some of my students doing, like the continuum emission stuff. Right now, pure discovery, atmospheric, neutral coupling, and things like this, right? But there's this equal partner on our instrumentation that we include in the design of the instrumentation now, right? So one of the things that we do, the new program that's coming out, we built it into the instruments. It's written in there that there's enough headroom and computational processing power on all of these things to service multiple data streams in real time. And we wrote into the proposal the dedicated efforts to have those frameworks on the back end that can provide those higher level data products that engage the users. We don't serve everybody, but we've got a few targeted users that we're working towards, and that's enough to start building that value proposition. And so you're exactly right, Phil, but it just takes one to start that you can engage with. And usually in our system, we can find there's funding specifically for that. We have programs called Engage programs that allow you to find an industrial partner, and they will fund the academic side to go and work with that partner to figure out where the connection is. And so it's kind of leveraging these other programs that I think other fields in Canada have done a very good job of, and we're just learning because we've been kind of forced down this road that I think you guys are now joining us on.
Okay, so I'll chime in here. So not all of us are going to be able to produce operational products, but I think it's not at all a stretch for us to support DoD interests. It's been a broader impact under NSF all along. One of the things that you can address, the fact that AFOSR and ONR have people in the agency discussions for the meeting says that they're definitely interested in the kind of stuff we do. And Julie, when asked for examples, said, evolution of the structures in the solar wind. That's not operational. I mean, that's basic research, curiosity-driven research that is useful.
Yeah, and from our side, at the moment, we're not getting operational products out of the ASIs, right? Like this is just not where they are. But it's the packaging of the program that has worked really well. So this is a heterogeneous network, that supports all of these applications. And we always make the point, I was talking to Mark about this morning, right? You have to make the point every time that discovery-based science is a part of that process, right? Because if we don't understand the process or the processes that are going on in geospace, you can't even talk about impact. And I always look back at Steve, right? And I say, I write this in all my proposals. Like, we didn't know Steve existed, right? And so how can we talk about the ability to specify the space environment where we can honestly talk about impacts and error bars, and integrity of systems when we actually don't understand the fundamental modes of the system? And so I put that, I always like to show the TRL curve, right, where we're going. And I said that this TRL1 basic research is fundamental to being able to build out these applications. And so I try to package it all together. There's some that are sitting closer to the where they can provide products. Scintillation products are easy to sell these days. But then there's these other elements like the ASIs, especially the color ASIs, where we're doing it for public outreach, right? And so the full spectrum exists, and I've kind of packaged it together as a whole program.
Any more comments?
I just have a couple of comments. I think it's important for us to recognise that this problem of maintaining instrumentation looks quite different depending on the scale of the effort that's involved. And, in my time at the University of Alaska, which is about 30 years now, there's never been a time when we've really felt we've got a stable, ongoing source of funding that can fund even just our magnetometers. They're really simple instruments. Everybody wants the data, but you can't write a proposal to just fund some magnetometers for a few years, or it's really quite difficult to do because you have to demonstrate new science that'll come from them. But those simple instruments are ones that everybody wants, everybody needs, and it almost feels to me like we need a slightly different solicitation from our funding agencies, and maybe it isn't even NSF, because NSF are interested in discovery science, they're not really interested in operations, but maybe someone like NOAA, we could lobby to fund those relatively low-cost, inexpensive instruments. That's a completely different problem to funding an incoherent scatter radar, which involves much larger commitment. But on the other side of things, with the small instruments like images and magnetometers and various RF, low-cost ionosons or whatever, there's a lot of hobbyist and citizen science people putting up their own instruments that are also part of the mix now. So I think we're in a completely different environment than maybe what we were 30 years ago, where there was much less open science, much less citizen science participation. And so on the small end of things, I think we need a completely different model to fund it, personally. If things like magnetometers and images and what have you are going to be continuously available.
I was just going to add to that, the DAISY program, which some of you may be running, is NSF's attempt to generate these kinds of distributed small instruments or scientific instruments and networks. We probably need to make sure that transitions to something that isn't just it was a development project. Okay, the development project is done. If you really want these to hang around. And it's funny, I remember in some NASA, there was this whole NASA thing about missions have a prime mission and maybe you get an extended period and then they're done, right? But if it's a space weather providing thing, you need to have another class of support that basically says, we're running this to provide this base level data. It's kind of the same sort of thing. So we do need ways to do that. And in fact, transitioning the DAISY program from where it is now to the next phase is something that it probably worth paying attention to, because as I tried to mention a couple of days ago, these are really where a lot of the future different data sources are coming from, and they do measure things that these other techniques don't necessarily concentrate on. And diversity is good.
I can kind of double down on that, because in the Canadian landscape, The way it's worked, and Eric, if he's here, I don't know, I can't even see because the lights, but he's been advocating for a long time that Canada needs to decide what measurements should be long-term, like measurements that are available that the community can count on. And he's done a very good job of advocating that with the CSA, the idea that, Themis ASI, the community really does just count on it right now. Like, there's not much thought in using Themis ASI data anymore. Even those imagers are now 15, coming on 20 years old, right? And we're now working on a strategy to deploy new instruments and have it backwards compatible with Themis so that data set will live for, 30, 40 years. And there can be a long-term data set of auroral observations that are cross-calibrated. And so we've done that kind of style of funding with the CSA where they recognize the value of long-term data sets. And that's taken a lot of work, I think, to socialize those ideas with the Canadian Space Agency. And then these more dynamic instruments that come and go are accomplished via these innovation programs. And that's how T-REX was funded. I mean, T-REX, hate to tell the community, but like the T-REX, the depth of information you get out of the T-REX data cube will not live for like Themis, right? Those detectors, they're already on their way out. And so T-REX will be this kind of blip where we had information, and there's going to be this more baseline observations that are coming. And we're always working to enhance that. And we're hoping that the new complement through GDCG will include, the staple measurements that are like the Themis style, but now color. We're hoping to add red line observations to that continuous capacity and expand the coverage of, the GNSS and the rheometers and the spectrographs and so. But that's how we've been able to do it in Canada. I'm not going to say that we've been entirely successful because we are on, we call it the treadmill of funding, like this kind of 3-year cycle. I know CSA is working to break it, but we still are on that kind of cycle so we have some of the same issues, I guess, I would say. And I guess that's just a funding agency issue in terms of their budgetary obligations, as you would say, and their budgetary ability to move forward. I see Eric now.
I think one other key to getting an instrument or a facility on something that's important for being able to make the case for ongoing funding is that it's critically important that the data that you collect be easily and rapidly available to end users. So, for a couple of decades now, I've been running a Fabry-Perot spectrometer, which is a somewhat niche instrument, but the data that we get is placed on the web within a day of collection in an interface that's pretty simple, pretty basic, pretty easy to navigate. And I've been astonished over the years by how many people actually download and look at those data. It's just my little website running on a computer in my office, and lots of people use it. And I think if you want to make the case that your instrument or facility is important, you've got to demonstrate that people are using it. And we can look at server logs and show how many people are using the data. But it has to be easy and it has to be accessible. And if you're hosting a sounding rocket launch or something and the visiting scientists come in and you look at what they look at and you see the data sets that they find are important, the things that make data sets be important to end users is easy accessibility and easy interpretation of the data products. I think that's key to us making the case that our instruments are needed, is making the data just super easy to get to and use.
Also, when you were saying we have to prioritize what the national science needs to be done here in the United States, I also think that the problem that we're trying to address is a global problem. And I think distributed instruments, or facilities that are outside the United States are also important. And I think that Jicamarca has been doing that. Is one of the biggest observatories in the equatorial. And I think that it's important to keep it operating. And I think that the quality of data and the new upgrades that we're investing on, and I think that really it's important to be considered as part of the world problem that we need to provide data for the different satellite campaigns, like GDC, for example.
Go ahead. Yeah, yeah. Microphone is off.
Thank you. I had both a question and a comment. One of the interesting aspects, what we see on this slide, is international collaborations, and with example like Chinese Meridian Circle program. And as we know, China invests really a lot, in particular in ground-based instrumentation, and there were conversations about some large development of the order of probably hundreds of millions of dollars in ground-based instrumentation, which is, of course, really attractive for us as scientists to have that kind of data and to advance science. At the same time, we are in a situation when if we watch some communications and some discussions, ongoing discussions in Congress, where collaborations, in particular with a country like China, are not exactly, let's say, under more scrutiny than it was 10 years ago or 15 years ago. So as a community, we are in a very challenging situation. From science point of view, it would be super fantastic and fantastic opportunity to have these new instruments, benefit from these large investments, and to have new collaborations. But at the same time, we are in a very challenging situation if our agencies, let's say, strongly discourage exchanges with China. So I wanted to hear some thoughts, some discussions about strategies. What we as a community, what can we do about this?
I'll make a comment to that. Larissa has raised the point that the Chinese Meridian program has a lot of resources, and we've seen that in the SuperDARN community. They've rapidly built a chain of radars across the north of China, and it dramatically expands our capabilities. You know, scientifically, it's just a boon to everybody to have that coverage across East Asia. But then there's the flip side. How closely can we cooperate with the Chinese Meridian program? You know, signing an MOU to govern the relation a little, maybe that's not the right word, but to describe the relationship. Is that acceptable, or is that a hazardous undertaking? I asked that question, I have no answer.
So I'm reading the title here. It's like there are two levels. If you remove the for hard times, you have ground-based instrument strategies. And that can be done in easy times, but we didn't have that. So now we are adding the for hard times. It makes things worse because we have people, the community is fighting to keep their jobs. So we need to be careful when we say, okay, well, we need this, continue these strategies to maintain and to increase our ground-based instrumentation. That would not fly very easily. And related to this particular Chinese Meridian Circle program, we need to be careful. I mean, there are a lot of things that we need to focus, and just getting into this particular topic, it could be very challenging. Without going to the Chinese Meridian Circle program, we can say in the American sector, where we could have very nice international collaboration that would be less problematic, if you want to say. I'm not saying that we don't need to go the other side of the globe, but we need to be smart on the way that we present our international collaboration. And going back to this, for hard times is something that the times are telling us, that the time is telling us that perhaps the priority needs to be maintaining what we have, assuring that things continue working on view of new assets on space, and then have a longer project. At CEDAR community, for years, for decades, we've seen this distribution of funding for facilities that were basically radars. Ground-based instrumentation, not related to radar, didn't have the same level of support. And this is something that perhaps is start talking now with no an easy solution or a short-term solution, but just prepare for the years to come. That solution could be, I know, facilities that will include magnetometer change. There was a time that was talking about LiDARs that were part of the facilities that didn't work out. So this is something that needs like a careful analysis and going two phases, short-term and long-term.
I think Dan has a comment. Can I, Dan Bille?
Yeah, I guess related to this, I wanted to, Larissa already basically made the question, but I wanted to highlight this. It's not just a Chinese thing, because I know in Canada, in our field, for a very long time, like US collaboration has been very important for Canada. My main concern is, as the administration seems to be getting more isolationist, how realistic is it going forward for, I'm assuming it's obviously less potentially problematic to collaborate with Canadians, but even on the Canadian side, it seems like a little bit, it's not you, but threatening, on other aspects of things. So I'm just kind of like, how realistic is it going to be? Obviously, things are going to be more strained than it was. And, there's been collaborations, which, there's been some, money exchanging as well, which is probably now going to be less realistic. I'm not necessarily talking about that, but I just want to get kind of the vibe on, where it's going to be on all international collaborations, not just with the Chinese.
So I'll start off on that one. So I'm maybe naive, but, I'm still going to talk to you, Dan. And I'll continue to talk to our Chinese colleagues as well. And so I don't, we haven't been told don't at this point. We're kind of, just trying to read the tea leaves. And, I don't try to do that. I try to, until someone tells me not to do something, I'll ask for forgiveness later. But and NASA has had a prohibition on working directly with China for some time. Recently, at the SuperDAR meeting, one of our colleagues was talking to one of our Chinese colleagues, NASA colleague. He said, "It's okay to work with Chinese. You can be, work with them fine. You have to have a third party, there. It's separate, another country." So I think, maybe just one-on-one direct collaboration with China might be a problem, but SuperDARN, for example, we've got everybody, so I don't foresee a problem. And I think that's the way for our field, we need to have this global work, and it's completely justified to work with China. It's necessary. So
I'm just going to make one more comment. What's on the screen there is the Chinese Meridian Circle program, but there's the international Chinese Meridian Circle program, and that is a multi-country organization. It's getting on its feet, okay? It is not, it's working on the kind of organization that will identify it as an international program. So it is, reading the tea leaves, is that when it becomes a multi-country thing, and they're making strides toward that, then the language may change a bit because it's international. It isn't just one particular country. The other thing I will say is that it's what you mentioned, the field is global, right? The atmosphere goes where the atmosphere goes, and it's organized by physics. It's not organized by, national borders. And in some of the discussions that we've had with, congressional staffers and what have you, it's important to make them understand that in science, our science has to be global. We cannot just restrict it only to one continent. I mean, we left that behind decades ago, and there's just no way that we could continue in that mode. So again, it's an education thing as well for the people who actually sign the checks, not even at the agencies, but above that. And so, I think you're going to hear on Friday some attempts to also fold that into what we're talking to people who are, signing budgets about. It is not something that this community has done as much of before, but I think we're all going to have to learn how to do that sort of stuff.
I was just going to add that, in making these decisions, there's a timescale associated with each of the decisions, and right at the moment, many institutions are facing immediate issues with funding that have to be addressed immediately. But things like establishing international collaborations, part of the job of the CEDAR Science Steering Committee is to take a long view with regard to the health of the field. And so if we can establish collaborations and keep them alive, we may not make them a prominent part of our activity in the next year, but if we, everything comes in cycles, and if we have partnerships, and if we have instruments, Chinese SuperDARN radars that we're collaborating with, as time goes on, that will be part of the resource that our community has to work with. And so I think it behooves us to also take a long view and say, well, we want to protect things that we think will be of benefit in the future, even if in the immediate next couple of years we don't make that a prominent part of our activity. We need to keep it as part of our longer-term vision, I think.
So since we can't really read tea leaves, we do have a small data point in recent, we were asked to rebudget for our current proposal. And one of the things that we were directed to make sure is that we could continue to participate in the international SuperDARN network.
I want to chime in on the international aspect of it, because some of the policies that we have been seeing for natural hazards, whether it is mitigation or emergency responses, is downsizing, for example, FEMA to a more state-level response. And if you actually read some of the policy that they're trying to implement, that includes space weather. So to me, that even breaks it down to a point that is the measurements are irrelevant, right? We can do state-level space weather. So communicating that we need the global measurements, this is, of course, it's the US, but it's beyond the US. It's the international collaboration and the way we do science. That's the only way that we can approach space weather. Any comments from the audience? Questions? Concerns? Yes.
So sorry if I came in a bit late, so if this was already covered, I apologize. But one of the things that, this is largely ground-based driven discussion. And if the NASA budget unfolds the way the NASA budget looks like it's going to unfold, or the way it's on paper now, then that means that things go away. That, for instance, in Canada, the Canadian Space Agency has bought into a way of doing business that is, from their perspective, to support things that are going on, in particular at NASA. And if those things go away, I've already had a conversation with one person at the Canadian Space Agency who told me, well, there are people who are saying, right now, because funding's tight at the CSA, people are saying, well, if those missions go away, then our obligation to those missions go away, and that frees up that money, right? And so from the point of view of the ground-based, one thing I'm particularly interested in is developing a feeling that, or developing the sort of sense that this is a storm that we have to weather, and that the ground-based becomes relatively more important as opposed to relatively less important if certain unfortunate things unfold the way they might unfold, right? And so, you know, we'll be looking to people in the U.S. community, for instance, for, in particular, Themis ASI, because that's the one that's most at risk, right? Is that because it's tied to a specific thing. But I would argue that Themis ASI becomes relatively more important if we have less data from space. And so it's just a comment. There's nothing to really do here, but you know, it will tell you why you're going to get some requests from us for letters, you know, as we move forward, depending upon how things happen. And again, I don't want to live in this world. I mean, I would not choose the path that the U.S. administration is trying to choose, but we have to live in the real world.
I will add to that, Eric, a little bit. Speaking from the international piece and, you know, our perspective, one of the arguments, just finished up a proposal on this, but the idea of space as a shared domain, right? No matter how you want to move forward with space-based technologies or the space environment or space weather, space is fundamentally different than other fields where it's a shared domain, and we're not getting around that anytime soon. So international collaboration and cooperation is actually fundamental to moving forward with advancing, you know, interests for the space domain. And from a perspective, the Canadian perspective, and certainly we've gone through this now, kind of Daniel kind of alluded at it, but you know, we were always internally doing the risk strategy and risk mitigation planning, and you know, what's going on in the U.S. right now is now influencing our risk for moving forward. So we're having those discussions, as Eric's saying, with the Canadian Space Agency about what are we going to do if. And the Canadian perspective that I've heard a lot from our own internal institution is, you know, expanding collaborations with Europe, right, and deepening those collaborations, looking to other, you know, to ESA, for example, for leveraging into ESA missions and things like that. So it is changing the landscape of how we handle things, but that does not mean that Canada doesn't want to collaborate with the U.S. I mean, certainly everything we do, as Eric says, like we're integrated, I feel like, because of the connections via the space environment piece, and particularly the ground-based, right? We're integrated into this community, so I'm happy to be here. And so that's not going away anytime soon, but there is an element of risk mitigation moving forward, and certainly you guys have your own risk mitigation of how you're going to handle things, and it's going on, I would say, for every agency or international partnership.
I'll just comment that I think these are sensible steps for you to take, not just wait passively to see how this current storm turns out. You know, going back to Eric's comment that, you know, if one of these bad scenarios unfolds, the value of ground-based is enhanced. And I think that's true. I mean, it keeps space science going, and it'll be a larger part of the portfolio of space science instrumentation. It's not something that, you know, look forward to or anticipate, but that would be the reality for continuing to do science. But I don't think NASA, for example, would necessarily ramp up support for ground-based. Without the space efforts, their interest is likely to fade. I would hope for otherwise, but realistically, I think that would probably not turn out favorably.
Just to speak, thanks, Mike, for that. And again, my feeling wouldn't be that NASA would ramp up its support for ground-based, but it's more to keep the pressure on the agencies that do support ground-based to not use this when they clearly see the opportunity to justify freeing up some money to do other things, right? So from our perspective, the CSA funds ground-based stuff, and I'm terrified that they'll say, well, okay, we're out now, right? And not so much that NASA would come in and raise our resources, but that we don't lose our resources, you know? That's,
The other half of that, Eric, is that as the international landscape changes, different agencies and different nations will find strategic opportunities, right? As things start to shift, and you can kind of see it in the Canadian landscape already as things unfold. Like there's strategic hiring going on in Canada, right? This is well known, and the same thing. This is true. This is true. Yep.
So is Canada running a malign talent recruitment program?
I am saying that we have had discussions with government officials about, things are going on in the U.S. and how, everybody is shocked and this is not a good situation. And can Canada do something to help out with the situation by hiring people? And that's a strategic advantage to Canada. I mean, it's sad, but at the same time, it is a strategic advantage, and Europe will be doing the same thing as funding levels drop. And this is not just our field, right? This is all fields, and you hear about these high-profile people being basically headhunted to Europe, right, in quantum and other fields coming out of the U.S. But getting back to the ground-based perspective, one of the options, or that we would like to sell, to the Canadian Space Agency, is this is a reason to double down on the efforts, right? That as the community starts to struggle, Canada can play a larger role in the international community if we invest now. And so maybe that's something that could be leveraged into by the U.S. community. As we start to try to expand our networks and things like that, is there things that we can do to then support the U.S. community leveraging back into that? And can we kind of ladder ourselves up even though we're struggling? And these are the things that are going through our heads as we're looking, 5 years, 10 years out. We're not trying to do
No, I was joking. But no, I see the sense of it, certainly. And I don't see it as malign at all.
I do have a question, but I'm going to switch gear. Yeah, Shunrong, go ahead.
Sorry, I had to give another talk in a different session. Just coming over. I noticed on the top line here, you say this Chinese Meridian Circle Program, and that is not true. Unfortunately, I cannot speak on behalf of Meridian Project because MIT does not allow me to deeply involve in that project. But this is an international Meridian project involving many different countries, even though it's led by Chinese scientists. This is a multi-international effort. That's the only thing I want to say. Thank you.
Just in case, these slides are by Bob Robinson, who wanted to contribute to the session. But yeah, you're right, this is the IMCP. Maybe. Yeah.
Yeah.
Thank you. Thank you. I have a question for all of you, unless any question, comment from the audience. This is a conversation between you and the panelists. So now that we will probably move towards harder times, I think maintaining a cohesiveness of what's needed, talking about that global observations of the space weather and the geospace in general, and maintaining the heterogeneous observations that we have, creating that cohesiveness among us is very important. But I can also see that it's human nature that when we are drowning, we tend to just try to save ourselves. How do we move forward giving that? Like, what would be the message that, and this is for everyone, I know there are several PIs sitting in the room right now. So how do we move forward trying to maintain that cohesiveness that we need?
So I was in the session on Monday that Phil was talking about the decadal survey. And you're talking about ITM and how the ITM, the charge when you develop the decadal plan was that GDC was going.
Right.
And to build the plan around GDC, right? And it's a big plan, right? And one, as a country and as a world, right, we can make choices going forward, such as we could say, well, GDC's not going, so let's scrap the plan, right? But another way to look at it is, okay, GDC's not going, but we have a plan, the community bought into that plan, and it's an exciting plan. Are there things that we could do to recover most of the possible science outlined in that plan? Right? Is there a SMEX path? Right? Is there a ground-based path that, so rather than collapse and balkanize, right? Is there a more aggressive, positive way forward? And I personally think there are things that we could do that are, where the resources that are going to be there could actually enable most of that plan to be carried out. And it's just it's a suggestion. I'm saying this from Canada, right? I'm saying it from Iowa, but I'm a Canadian saying it from Iowa. But it's a thought.
Okay, so I am not a Canadian and I'm in Iowa. So, yeah, I think, Eric, some of us who were involved in the decadal have begun to talk about that kind of different set of conclusions, if you will, because the decadal was of its time, and we are not in that time any longer. And so, but it isn't that we don't have possibilities of things we can do. I'll just say the Academy's process is a very complicated one, and this is probably nothing official from the Academies. This may just be those of us who are involved with it kind of discussing how to do that. So it is one way to sort of provide some things that look a little more unified, like you were saying, is rather than individuals, trying to row their own lifeboat. It is kind of where we need to go, I think. So yeah, you're not the only one that's been thinking about that.
I think in terms of the cohesiveness question that Bayer asked, one of the things that we've been doing for a long time, and I think does help with cohesiveness, is the whole open science initiative and people, sharing their data and making data available. It's like I was saying before, make your data available easily and simply. And as soon as, what I have seen in my career is by doing that, so many opportunities have come to me because people have looked at my data and said, oh, I would like to try doing this. So I think just emphasizing the instruments that we do have and the capabilities we do have, if we try and move as much as we can to an open science model and make those data as freely available as possible, I think that will help with the cohesiveness question at least.
I will just add, and that's also part of the education, that sharing data in an open manner is a good thing. And we've referred to that a couple of times before, is that you can't not assume that everyone you're talking to just intuitively understands that. You have to demonstrate it. And that's, again, a bit of an attitude shift that we have to do, is like we have to make the case that that's the way that yields the most benefit for the investment that's been put in to, some cases, decades and decades worth of observations, and which have an aggregate total of investment that's pretty staggering if you add it all up, frankly.
Your idea, Eric, I think is good, but could be dangerous. I agree that, let's assume that these missions are not going up, so resources should be put, or the planning should be focused on ground-based, but not at the expense of saying, well, we will be able to solve similar science questions with the ground-based, but maybe aiming to something different, because a few years from now, when you say, well, there were those two missions proposed, And they ended up doing with ground-based and was solved. So that means that maybe we don't need another kind of mission. So it's focusing on the ground-based, but maybe going through different science questions, for example.
I think we're not at risk of solving a lot of these problems, you know. I take your point, Carlos, but I mean, my question, I guess, as I was sitting here, you know, and I appreciate being given, you know, a voice here, but is the decadal plan still our plan? That's, I guess, my question. Right? Or is it just now, well, I mean, there's stormy waters, and so it's no longer our plan, or is it our plan? And if it's our plan, open science is in the plan, right? I mean, sharing data is in the plan, right? These things are in the plan, right? And so, yeah, we'll do that because we said we would in the plan, right? And we'll attack these problems because we said these were the problems of today. Maybe we won't do as good a job because we don't have exactly the resources, but we said these are the problems we should solve now. Right? And so my question is this still our plan?
That's a good point.
So while they're passing mic across, I'll chime in here a little bit. So I was involved in the GDC discussions as part of the instrument teams, and we had this ground-based discussion. And I would say 90% of what we put into the STM was ground-based. There are certain things you can't solve without having that, you know, mass spec in the you know, in space. But there's an awful lot of the plan that we can do from the ground. And it is a good plan. That's why, you know, GDC was proposed in the first place. It is the science we should be doing. So, but we should have the discussion of, you know, we have these assets now. What, you know, again, what's, you know, maybe not redo the decadal survey, but expand the discussion.
I was going to refer to the famous quote regarding plans for going to war. They said there's no war plan that survives any longer than the first night of contact with the enemy. And, you know, we might be in that realm that with this fundamental change, maybe we do need to reevaluate a little bit. And I want to maybe pick up on what Carlos said, and what I'm about to say might be a bit controversial, but I'll try anyway. You know, I think most things in the physical world end up where they are as a result of the stabilizing effect of a negative feedback loop. So, you know, some change happens and there's a restoring force that opposes it and it brings it back to equilibrium. What we're experiencing now is a change that's impacting our science in a negative way. If we show the end users that we can still do everything we would have done without these big missions, we don't get the negative feedback. You know, we have to show our end users that if we don't have these capabilities, then there's a consequence and there's a loss involved. So if that means that some of our spacecraft that provide solar wind data don't continue to do it, that will be immediately noticed, and people will want to address that. Or some, you know, if there's an operational need that can't be met, that's the thing that will result in people going, oh my gosh, we need to address that and we need to solve this problem. So I think, you know, if we're going to be, if our funding is going to be limited, you know, to some extent we need to demonstrate to the end users that there's a consequence to that, and what we were doing was actually useful and beneficial, and if they don't have it anymore, then, you know, that there's a consequence. So trying to achieve everything we would have done without those sensors might not be, in the long term, the best strategy. And I know that's probably controversial, and Eric's about to tell me I'm wrong, but it is a thought.
I mean, I agree with most of what you said, you know, and I would say that I'm not suggesting that we can do everything we said we were going to do. But I am suggesting that if we keep working in the same direction, yeah, we'll do less. If you have $200 million versus $1 billion, you're going to do less, right? But are those the things we should work on, is my question, right? Like, of course we'll do less, you know, but And if there's a recovery in 2 years, let's say that this is a downturn and there's a recovery. And then if we abandon the path that we're on, how do we go back in 2 years and say, no, that was the right path? Right? It's just again, this is really, it's your community, right? It's not, I'm just tossing out some ideas, but
so my own personal answer to that would be that if in 2 years' time there's a realization that the downsizing wasn't a good idea and we need to go back, I personally think that we will have to reevaluate, because things like these missions, the teams that were going to build those instruments, a lot of those people may not be there in 2 years' time because the labs can't keep people together. The way that the groups have evolved will have changed. So I don't think it'll be possible to just pick up exactly as we were going to do it. Maybe the end goal will look similar, but there will have to be a reevaluation, I think, because we just won't have the same starting point as what we had a couple of years ago. I would say that, in everything we do, the thing that enables you to get a proposal funded is ultimately that you can demonstrate that there's a problem. We don't say we're going to build an instrument because it'll do this great thing. We say we're going to embark on this project because it will do this great thing. Really, the way to get something funded is to say we're going to embark on this effort because here's a problem that needs to be solved. And so what we do in the interim, I think, is probably going to be to continue with the resources that we have and continue to explore the things that find out the things that we don't understand and use those to drive where we go in the future. So, that picture of what needs to be addressed, things change quickly, and in a few years' time, it might look different.
Any other comment? No? This discussion is really important, actually. So I want to go back a little bit and think about the open data. So as a person that is, you can tell by the accent, international, my career was benefited by having those open data. And a personal concern is, on one hand, if we don't have funding, is that database going to stay open forever? We always assume it's going to be. But on the other side is, if we're thinking China is going to maintain that instrumentation or expand the instrumentation in the area where they are and in the International Meridian Circle, how open is that data going to be? Do any of you have information about that?
Again, I'm not allowed to say on behalf of them, but I can give you a little bit of information. So they have a bunch of instrumentation plans, and those will be set up in other countries other than China. And the idea is to have multiple international data centers, like American Data Center, South American Data Center. So the discussion was trying to use some kind of open source software like Madrigal to manage the data and share the data to the entire community. So that's still under the discussion. I don't think there's major problems with them. And right now at MIT and Madrigal, we are getting data from them on a daily basis. So I don't see major concerns in terms of this international effort. But a domestic project can be a different story. And most of the times, you need to contact the PIs, and most of the PI are open to make data available. That's what I know.
So I will say for SuperDarn, our colleagues in China have committed to putting their data on the database. They actually host one of our data mirrors in China. There was a period of about a year before they could put it on the mirror. They called it a commissioning period, but they are putting it on there now. So.
That is wonderful news. I'm very excited about that. Can we switch gears? So we still have like 40 minutes, so maybe we can end in a more exciting note and talk a little bit about the data. We all use the data as an early career person. one of the things that have helped me a lot is having tools for analyzing data. So many of the arrays that we use have provided those tools. We have the Python tools for SuperDarn, for example. I know Calgary has been developing tools in IDL and Python too. So is there a way, so if I think, for example, in Themis, that they have been plugging in different libraries, so you can easily combine not only the data from the spacecraft, but also from the ground-based instrumentation. Is there a way that we can all do that in a more consistent way? Maybe this is a naive question because all the instruments operate different, produce different data products, but I think this could be a great benefit for the community.
So I absolutely agree. Having the tools to make the data accessible is absolutely necessary. The SuperDarn model is probably a pretty good one for that, in that we have done this from the beginning, and it has always been a collaboration among the groups. And you know, if the idea is developing international networks in the future, in the beginning, there was a lot of work done by folks at Leicester University and at APL. And Leicester University is not doing as much these days because people have moved on. They are less well funded than they were originally. But now our colleagues in Canada are leading the charge and have done great development work. So some effort like that is large international group. Different groups are going to be up and down at different times. But that having working groups among all of the participants is a huge help. I think if you are going to do something like this in the future, it's a necessity.
I can add to that a little bit from our experience. So I think, what you're getting at, I think a little bit is that we've moved beyond just open data. And now it's no longer enough to just put your data on an FTP site and say, good luck. It's really about supporting the users through the tooling, and that includes like searchability of data availability, summary plots, and these types of things. Certainly from our perspective, from what we have in Canada in terms of this kind of heterogeneous set of sensors, there really is a barrier for users, particularly ECRs, as you come through, because the details of the data matter, and the details of the acquisition matter. So while we've been also developing Python tooling and IDL tooling, I will remind people that IDL users still exist. One of our surveys, it was sort of 25% or so of users still use IDL. So our tooling is available in IDL and in Python. But the idea that we stack our tooling with these things we call crib sheets. So we went back to the old Themis days where, the original Themis satellite data I could download, the way Bob McFerrin or whoever would look at data, or you could go through and see how the data providers would use the data and how they would load it and how they would do it. And you could take their code and you could use it. And so we've got a bunch of those kind of examples. But in terms of the larger utility of the data across networks and across comparing to SuperDarn and such, we've tried to invest in what we call these higher level data products, where we're trying to remove the instrument from the data product. So you don't have to know which cameras are on or things like that. We've produced a higher level data product that comes from the entire network, where we as Calgary have looked at the data and used whatever processes we have for validation or verification, and we've given you the best high level gridded product that we have that includes all the instruments. And so you don't have to think about, do I use Rankin Inlet and Taloyoak, or what's the problem right now with Rabbit Lake, right? We've taken care of that, and you get a simplified data product where you don't have to think about the details of the acquisition or the systems themselves. And I think that'll be an enabling factor when we want to start comparing to SuperDarn, for example, because you've got this simplified grid from the ASIs where you don't have to worry about it so much, and it really does lower that barrier of access and interpretation to the user. And now I see Daniel has his hand.
Yeah, I can speak to the SuperDARN Python tools. One thing we're proud of that I encourage everybody developing their tools to do is make it easy to use with like things that people do in Python. So when you wanted to plot SuperDARN data with PyDARN, you don't have to use, there's tools to just make, a typical SuperDARN plot with it, but you could also just, pass in your own axis and overlay on your current data. So if you're working in magnetic coordinates, you can just give it that and it will just overlay SuperDARN data. So it plays well. So I think that's really important to encourage people to not only just download your data, which may or may not be easily accessible, but also like use the data. Making that as easy as possible is something that we're really keen on doing.
And to double down on that, that's the idea behind these crib sheets approach that we have. Coupled to the old Themis things, right? Like it was, you got the code that you could use and I could stop the code at any point and add my own thing in because I knew what was where and where the data was and in what state it was. And so all of that, I feel like those efforts are appreciated by particularly the ECRs. I know my students, when they come in and we just throw them at the libraries, they all come back with, oh, okay, it totally makes sense. And then you can insert your own things at certain elements. You could bring in the SuperDARN tooling, right? You could stop the code and put in the elements that would then bring the SuperDARN over top. So I feel like that speaks to the interoperability of the tools by blowing open not only, the functions, but how to use those functions and how to string them together and giving people those examples of how do I build, as the Calgary group, how do I build a stack plot, right? And then how do I overplot, the time when swarm flew through this field of view, right? It's all there in a documented way of how one could go about that process. Not just using, functions, but we publish or make available to it the process by which you would engage with those individual functions to build, some analysis tools of your own.
And on the Hicamarca side, you can see that the data is always available, open access. Through Madrigal, we also generate a Madrigal version of the thing that you can actually see the plots, so you can easily see what kind of data is available over there. We can see that for the real-time experiments, you can find on the website what kind of instantaneous product we are generating. And also, we operate some other ground-based instruments, not only in Peru, but also in South America. So you can find it also, the LISTEN network, ionosones, GNSS, GPS, magnetometers data that is always available. And if we need to be in a different standard mode of the data that all the community can use it, I think we can work on that and reinterpret the data to be sampled in a different way that it will be easily accessed for everyone.
Yeah, and I can make a couple of comments. So Madrigal is an interesting thing because it's got all of these heterogeneous instruments in them, all of which measure different things on different cadences. And so I can just say that one thing we do is when we ingest data, we make sure that the provider gives you a static set of summary plots because there's the discovery part and then there's the analysis part. You can't analyze something that you don't know you want to use, right? And so having at least a discovery set of static summary plots will at least get you to the point where I want to look at that. At a higher level, anybody in here used autoplot? Anybody used that? Okay, so a few people. So in the satellite community, that's a pretty cool thing in that it attempts to fuse together a bunch of disparate things and do the common stuff like, okay, let's put it on a common, for example, magnetic coordinate or what have you. Some of us have had a couple thoughts about also trying to wire in some things from the ground-based community there, not only for discovery, but to do common things. The last thing I'll say is that for anybody who's been to one of our ISR one-week crash course summer schools, our goal is to basically get people, first of all, knowing that the data exists and to be able to do basic things with it. And guess what happens? We have notebooks, right? Python notebooks that we can give people as, here's a way to generate a summary plot, and now you can begin to tweak, right? That works pretty well. But the first thing they do is, well, but I want to also look at TEC, and how can I actually grab TEC at the same time that I'm looking at the radar data? So almost instantly they go to, I need multiple instruments, and I want to understand how to put them on a common framework. It just happens organically. And so we're trying to, and I think that's what I'm hearing, is developing better tools to at least get one to the, what does this really mean, scratching heads case faster. We have a long way to go for that, okay? And as you said, it's a large community and not everybody uses the same tools. But I think we're trying to make progress there. So but I'll end with a note to funding agencies to fund people to actually write these kinds of things rather than just assume that you're going to do it subsidized by somebody else in your spare time, because you get what you pay for in that case.
I can add one point to that, Phil. So yes, and in our experience, we've been able to successfully argue that developing the tools is the data provider's problem. And it is their responsibility when you're putting data out into the community, you need to provide the tools that ensure the verification, validation, and proper use of that data. And that's hence our crib sheet approach, right? Like, so this is how we access our data, this is how we use it. You get to see how I make a mosaic, how I overplot locations of rheometers, how I add a stack plot of this or of that, how we pull out the luminosity in a certain bounding box. So we've been able to argue that as part of the operational costs of the network are that the data providers will make and maintain these tools so that the tools maintain their relevance through the entire operational life cycle of those instruments. And I think that's, to me, that's a natural way forward, and it's a natural argument to make because you are the person with the expertise, right? You know how that people should be doing. You know what people should not be doing with your data, right? And so by putting out your own tools and your own methodologies and describing it, you're educating the community of how people should interact with your data. And I feel like that's fundamental to long-term operations and utilization of the data to kind of maximize its use in the community.
Going back to your question, Bea, regarding all-sky imagers and cohesivity of different systems, we are way behind, as SuperDARN was showing that they have like a common format. You can do whatever you want with different instruments. You take Mango Network, the BU network, Calgary, OMTI, Shiokawa network. There is not a common set of tools that would say, okay, let's open Lucky Lake, or let's go Paratunca and El Leoncito and apply. We don't have that. We are relying on trusting you guys. You have very good tools of Mosaic, so I think that's a way to go, trying to get some kind of common format that will allow a user to go and check on that. We are behind on the tools BU, but we try, for example, to keep the data coming online, basically in real time, so you can access. There is a link in Madrigal to access the data, but the problem is that when you have a quick look image, you cannot extract immediately information that you can compare with GLOW or other things because you need to do a more heavy processing calibration process.
So I can react a little bit to that because I feel like you're setting me up. So the Aurora X tooling is what Carlos is referring to. And it's no accident that it's aurorax.space. It's not aurorax.ucalgary.ca, right? And it's no accident that when you access the tools and you're looking at the way to access the data, right, you end up with aurorax.ucalgary.data-download, right? There's room in there, and it was done intentionally, to be able to provide a place for other institutions to have code bases of their own that would then be accessible, maintained by themselves, specifically giving credit by the fact that you have to go .ucalgary.download so that the user knows, by doing this, like that's the uCalgary stuff, right? And it could be, .sri, .download, or whatever. But it's known to the user, and that this could be perhaps in the future leveraged as a community resource for the imagers. And we did specifically build it that way. And then some of the common framework that can be engaged is once we get the data in and it loads in a certain way, you can use the other tools. They can port right over, .keogram, .mosaic, right? And the multi-network mosaicing that we have right now, because you can plot a mosaic that includes Themis, Rego, RGB, all on the same plot. That would allow us to have multi-network and include, for example, your imagers on the same mosaic plot. So we're working towards that, and we definitely recognize that in that respect, we're a little bit ahead. But again, that's only because I feel like we've been successful in arguing that it's our responsibility to ensure that these tools are there for the community, for the validation of the data and so on. So we would look forward to the collaboration that we are hoping to forge to get other imager data sets fully integrated into Aurora X.
Go ahead, Larissa.
Yes, I just want. Oh, wow. I just wanted to make a comment in the spirit of this discussion. When we talk about Madrigal database is a tool itself is a distributed database system, and I just wanted to remind that just recently, in the end of 2024, actually in September 2024, Madrigal database there is an open Madrigal initiative, which means that Madrigal is open source. It is available on GitHub, which means that anybody can look at the code and keep developing. And in particular, I am strongly encouraging that people have free time, curious minds, and can keep contributing to developing, not just relying on limited resources or waiting for something to be done. People can actively contribute to the development. We already discussed these things that, really as developing tools, in particular people in other organizations, other countries. I think this is another open opportunity for us to keep improving our tools. Just wanted to remind people.
So, if I'm correct, Madrigal was originally a supported program to create the software in the first place, and you guys are being supported to do this. That's great. SuperMag was supported to do what So why haven't you written the SuperLoom proposal yet, Carlos?
Well, yes, you're right. Why not?
Yes.
Exactly. That's a good point.
It takes money to do these things.
It takes money, yes. And right now, for example, in our case, there is marginal support from NSF to do all the maintenance and all the pre-processing, and we are trying to develop tools that will allow if someone wants to see the data, let's say, unwarped, we can give or the tool or the data already unwarped. But ideally, yes, that's part of the strategy that we need to decide if we need for different instruments, not only all-sky imagers, no, FPIs, for example.
I wanted to interject, answering Bill's question with a maybe provocative statement, which is I'm going to ask that as a community, we think more truly internationally, because you're going to Madrigal, right? And I would say, Emma, in my name, Emma wrote that proposal that you're referring to for Aurora X, and we've received the funding for Aurora X, and we have ongoing funding for Aurora X, and it is meant to be that thing, right? It exists. It's funded. And the problem with the optical community, and again, I'm talking to friends here, right? So the problem with the optical community is that the optical community, more so than the other communities, tends to be a little bit more prima donna-ish, right? And that we all do things our own way, right? And so you have nothing that even vaguely resembles the SuperDarn data, right? Which is highly uniform around the world. And the SuperMag is possible because, frankly speaking, the magnetometer data is so simple. That's what makes it possible, right? But with the cameras, we have all the problems that you have of the radars. All of them and more. All of them. We have all the problems you have with the radars, calibration, all of this. What are the units? What do the numbers mean? We've got wavelength, right? We've got, or is it white light? Is it filtered? Is it this? Is it that? And we all do different things. The Mango data is dramatically different than the Themis ASI data, which is dramatically different than Carlos's data, which is dramatically different than Kazuo's data, and so on, right? And so it's a very challenging problem. And having buy-in to a funded initiative would be a step in the right way, in the right direction. And the first step in that would be people, other PIs, and some have done this, and Carlos is trying with us, and Neuropartemies and is doing this with us, but making uniform summary products, keyograms that all are, they are the same thing from every array, from every camera, right? This sort of thing would be a great step in the right way, especially addressing the question of discoverability. But that's my 2 cents worth.
Thank you. No responses? Oh.
Is that 2 cents Canadian?
Just a minor comment on that, not so much with the images, but with the interferometers. A problem I've struggled with for decades is that just the dimensionality of my data is different to everybody else's. And that makes, so I'm 100% on board with standards. I think, the only way technology works is by having standards. And the fact that your laptop can communicate to the conference Wi-Fi is because there's a standard. And standards are what enables progress. But for me, it is a struggle because I said my data do look so different to everybody else's, and I have to figure out some way of getting past that. And I don't think I've done a very good job of doing that. But to the extent that things can be standardized, they should, absolutely.
I will just say we're getting back to workforce development, folks, because we are blessed with a heterogeneous set of measurements in this field, and just throwing them all on the table is the start of figuring out what to do. And so training, right, is very important. If you just say to people, well, here's the paper, just do that. No, that doesn't work. They'll find something. These are, I keep saying this, these are clever people. Clever people have clever things they can do, and you don't want to put a barrier in front of them doing the clever thing in this area as opposed to the clever thing in some other area. And so, it's the workforce. It's all tied to that. It is what you're trying to do in Canada. It's what we're trying to do in the US with various things.
Just thinking about another set of data, thinking TEC, and I realized that out of quickly thinking, there are like 3 places where you can look at TEC products. MIT, Haystack, the Japanese, Nagoya, and Embry-Riddle, I think they're doing something. And when you want to see the data, it's like you can pick. And I don't know if all the results will be the same. So we are not requiring any kind of cohesivity in those data sets. Should we? Or how do we decide that the method that Haystack uses is the best or not? Is that important? But I mean, there's a question, not being an expert on TEC, when I look, I'm careful just to say, okay, should I be using this set of data or this other set of data?
If I changed a few words, it's exactly the discussion we just had about optical data, which is there's this, there's that, there's that, the other thing. Is the question which is the best? No. The question is, how do you fuse together all of these different things, right? Which is getting back to what Emma was talking about having a platform where you can try to look at those. And I'll I'll mention workforce again, though. Also, it means that there are people who don't bite that you can actually call up and get advice in that sense. And you've got to have both of those, I think.
There is a different dimension here. It's like these TC maps, they all use the same receivers. The optical, they have different sensors.
Well, that's the flavor of difference, but there is difference. I mean, it's heterogeneous, right? That's a strength if you can figure out how to use the strength correctly. And we're all still working on that part. But some of the exciting things that we've seen, we just had we had Easy. Easy is coming out and is making 118 gigahertz, Zeeman splitting measurements, which are going to tell you certain things. Boy, it's going to take us a bit to actually understand how to use that and incorporate it in everything else we do. It's exciting, but it's going to require work to actually get people to use that. And you can look at any instrument in Madrigal, and it's the same way. It is communities like this one and workshops like this one where we can actually try to put those pieces together. And SuperDarn does a lot of things that, you have a uniform product, but that's not the only thing by far that comes out of SuperDarn. And those are different strategies to use those different products. And that's where the innovation comes in, I think.
Yeah, I wanted to comment on that point, is that the radar data, it's a complex data set, and it's not quite as straightforward as just putting product out there and validation tools. All our displays recommend that a user contact a SuperDarn person for help with interpretation. And it's a bit of an issue that plots get, if you make the plots really useful for people, they come and get it, they download it, it goes into presentations and publications, and that consultation never happens, or it happens at such a late point that it can't really contribute to the study. And so there is that issue with getting the data out there. So tracking, logging, getting credit for it, that's one part of it. The other part that concerns me more is making sure people have the best data product in their hands, which can only really come about with a complex data set if there's consultation with an expert on it. And it's unrealistic to expect, the general user to become an expert and become more knowledgeable with time. But there is a need for an interaction with a person who has deep insight into the data.
Just a little anecdote. At some point, I was using radar data from different places and relying on the people that know to get the data. Then I found out that using Midstone Hill data, you make some assumptions regarding TE and TI in nighttime, obviously for you. You go to Arecibo, and the assumption is different. And you go to Jicamarca, the assumption is different.
Yep.
So I was on open eyes, like, wow. I thought that, you have the radar, you do, extract the line, whatever is it, and that's it. But no, you need to make assumptions and changes in different locations and radar. So.
Thanks to the panel members, because I was going directly towards that direction in the discussion. So one of the things that we mentioned at the beginning and that you all have touched on is there is a cost, there is an effort on deploying, on operating instruments, and when we ask about tools, we might not even have the funding many times to develop those tools, and that is a problem that we all have. And I imagine if the array is smaller, the money to spare to develop those tools is even less. So that's definitely a problem that needs to be solved. We have identified it, and now we need to solve. But I'm not going to jump into the funding issue again, so we can end in a happier note. Phil, go ahead, interrupt me.
No, I was going to say, that's the whole DAISY networks, right? Smaller networks. They can't immediately do all of this heavy lifting that other people who have been doing it for longer have been doing. There's an exact analogy, by the way, to the small sat community. The small sat community is being told, do science on your platforms and make your NASA level 2 data, and these are small teams. Yes. And so can you find some ways to avoid them having to do all of the lifting? It's no different in this kind of community as people develop lower cost instruments that are in networks and that take even more head scratching to figure out how to get a good science variable out of them that has some good meaning in it without having to be such an expert, as Mike was talking about, that you are the person that literally built the instrument. So we need to learn how to do that better. But that stuff is already here. It's here now. It isn't just something that, well, in a few years we're going to have to worry about that. The community needs to understand how to do that now. And again, I think people are doing this in various ways, but it is unrealistic to assume that the professor with a couple of graduate students that starts to develop things is going to be able to get to this level right away. It's a community thing.
Yeah, definitely, definitely.
I can comment a little bit on that because as Eric is known to give away cameras, we have now been working with various other people who are these small operators, right? And we are having those discussions now about how do you operate one of our systems? What does it look like? What's it going to produce? You know, the data is going to flow back into our system for monitoring, and they're going to have access to those tools that we've already developed. So there's a level up when you kind of partner into these programs where you can leverage the expertise that we've developed through generations, academic generations, of development. And so we've got that. I mean, we came upon it, or I came upon it by accident because of Eric giving away cameras. But now we're working towards that kind of thing. And so the people who've worked on this for decades can now start to support these kind of younger teams, I would say. One aspect of that, though, that we're leveraging that's not really included in the kind of DAISY approach, I think, is the fact that it's uniform sensors when we do this, right? So when Eric goes around giving away things, they're all the same sensors, which is one thing that the community might want to think about, because especially with the optical community, we know, right? You run your cameras differently than ASTI than we do, right? And if you have 20 people doing that, we've got a different scale of a problem to try to bring it all together. And so maybe there's some discussions there to be had about leveraging into different groups or different technologies to make sure that there's an interoperability, like a core level of interoperability before we start. And it doesn't mean you have to buy Calgary cameras, but it means maybe having those discussions up front about how do we make it ahead of time, how do we do it by design that these can all work together as opposed to after the fact dealing with the wreckage.
Well, yeah. In fairness, you know, the reason there's this consistency across SuperDARN is it started with a single instrument or a couple of instruments, and all those that came after followed the standards that were first prescribed. And that's quite different from, you say, magnetometers or imagers that got going with groups with their own ideas about how to go about doing things.
Well, so SuperDARN has balkanized a bit since the early days, but we have maintained that we all have to have a data standard, and that's kind of the fundamental thing. Is that, and is that possible for the optical data to have some level at least where there is a standard that you could put, like the white light maps of Canada?
Yeah, I can speak to that because Eric had mentioned that point, right? That the standardization, just to start, of summary information to make the data sets discoverable, right? Step one is not going to be that, you know, we can all use the exact same tool to plot a gigantic mosaic of everything, but step one might be that there's commonality to the summary plots so that they can be virtual observatories and connecting data systems where, you know, your systems can browse our stuff if they exist, or your systems can leverage ours and your data's in there and it's discoverable and then people know to contact you. Right? That might be just step one, is that we can get a consensus on summary level of information and how we reference certain things. Like when we talk about timestamping exposures, are you timestamping the beginning of the exposure, the middle of the exposure, the end? Like we've had these discussions before, but yeah, standardization.
And I'll just point out that we had decadal conversations too. It's a spectrum, right? There should be a mix of common sensor sort of things where it's a little more straightforward to fuse a product together, and the heterogeneous kind of systems that you fuse at a higher level, because no one thing has all of the picture in it. It's the synthesis combination of them. And so it's not one, not the other. It's kind of somewhere in the middle. but it certainly would help to have some tools that are a little more uniform, like you're talking about.
And then being able to view the kind of opportunistic sensors, right? Because not everybody puts out cameras and they're looking at operating them for 20 years, right? You might want to operate it for a month because you're targeting something, you're targeting Steve, or you're targeting something continuum-based, but you want to make that data as well discoverable. So somehow the system has to accommodate these different levels of engagement in terms of data production.
Is Nathaniel Frizzell in the audience anywhere?
There we go.
Oh, great.
Hamsai.
I'm going to channel you, Nathaniel, for just one moment. Nathaniel will tell you, because he's lifted, he's created this thing called HamSci. It's got a lot of momentum. This is citizen data, and it has it is missing a lot of the qualities that we have in professional instruments, in that, it's not, calibration is a difficult problem. There's lots of things, and so a lot of his work has relied on binary things. Was there a radio wave going from point A to point B, right? What can one squeeze out of that for science? It turns out a lot. So that's the opportunistic thing that basically just says, okay, what can I work with without going the harder next step, which is maybe not appropriate for that set of opportunistic measurements. And I think the spectacular results that have been coming out of that show you that, yes, there's a lot you can do with really simple metadata, honestly. And that is not uniformly sampled, that comes and goes as someone is spending an hour doing the hobby stuff in their basement. There's a whole world of that out there. I hope I channeled you well enough.
I was going to add to what Emma had said, which is the whole point behind the summary data. I don't think the problem, like the optical data is so big, so heterogeneous. I don't think we're within even 5 years or 10 years of having a solution to that. But the summary data, what it does is it makes opportunities discoverable. Yep. Right? And one of the things that I've always been a fan of is that, if I can tell somebody very quickly, yes, this is useful, or no, this isn't useful for you, that's the best thing I can do for them, right? And then if it takes you weeks or months, right, to put data together, to write your paper and all of that, that's not a big deal. In fact, that's what makes a lot of people good scientists in the end, right? But being able to find things and to be confident that you've actually got the best information when you're writing your paper, because there's nothing more frustrating than, publishing something and then somebody comes out and says, yeah, but I've got even better optical data for that, but you just couldn't find it. And so the summary data for the optics, I think, is the next step that we ought to try to solve, to address.
Let me shift gears. We only have 5 more minutes. Some of you have talked about this, but this is, to me, very important because, as we all know, we rely on funding. To get funding, many times we have to talk about how much usage of our data is there. And for that, we go back to the papers. So on one hand, we need to have that data usage recognition that some of you mentioned. And you also mentioned that using the data and just recognizing the data sets that you're using is not enough. And this is a message for the community and probably for the younger side of the community. Something that several of you said is checking with the PI. So I'm not sure whether or not we have the code of conduct for the usage of the data. How can we help you as community to get the recognition that will help us at the end maintain the instruments that we love to use?
So I'll take a quick stab at that. So I think it varies a lot what's needed. At the lowest level, just getting the acknowledgement of grants so that we get credit at NSF or wherever is important. But I also know some of our super darn colleagues, it affects their promotion if they don't get the authorship on papers, and so different folks need different things, and so really talk to the person who is supplying the data to find out what they need.
Excellent point.
I can add to that a little bit because it's really a balance. So this whole, like the open science initiatives, right? So blowing your data wide open for people to use is fantastic. But there's the competing part of that by doing that, that puts pressure for us to try to figure out the ultimate users of our data, right? And so one of the ways that we do rely on the scientific community to really look at how to credit the data properly. We've moved to the DOI, like everybody now has been pushed towards that through the journal framework. But outside of that, being involved in those studies, if we can be, is very important. A lot of the time we do really want to collaborate. I can say by way of example, I was asked to review once a paper. I'm apologizing if you happen to be the author of this in the audience. But I was actually asked to review a paper that was based on ThemisASI, and it took me 3 seconds to figure out the entire paper was based on cloud. And it was one of those moments where I was like, I felt so bad for this person. They had invested significant effort, and it took me 3 seconds to go, this is not geophysical. And so from the user perspective, it's a risk mitigation strategy, perhaps, maybe to engage the data providers. We're more than happy to do it. We are always arguing for the value of our data in the community. We have to make that value proposition every time we compete for funding. And part of that is the utilization of the data. We do our best to track it through, not through access statistics and things like that, but nothing speaks more than our ability to engage with the community in a way that's meaningful for the study and meaningful for us to help provide, that perhaps guidance.
Exactly, I was thinking the same thing. In my case, it happened before the paper was submitted. So I got the message saying, okay, I'm doing this, I'm working with this data, it's a very nice CEDAR arc, happens to be, but going back, background data, no, that's the same structure, it was a cloud. Yeah. And then.
Yeah. So, there's someone.
Go ahead.
Okay, hi, this is Bhagyashree. I'm a PhD candidate at CU Boulder, and I am trying to use as many data sets as I can to figure out mesoscale drivers of GICs. And one of the issues that I run into often is, one, from a publication standpoint, if I'm using, say, 10 different data sets from different satellites, it gets in the way of my word count. So acknowledgements is counted as word count, and if I try to acknowledge everything, it takes away from the arguments that I'm trying to make. That's point number one. Something needs to happen about it. Second point is that if I'm using 10 different data sets, I am talking to 10 different PIs, which is not a problem, but it takes a really, really long time to get back and forth. And I wonder how realistic it is for PIs of different instruments to constantly talk to people and at the same time work. I'm just thinking about the mental workload about being productive as PIs and then answering questions from people like me who are trying to use all these data sets and convince them. And the third aspect is, of course, how long a data set is available sort of determines how much of a longitudinal study you can do to sort of do this data fusion process that I'm trying to do. Either way, so 3 points I wanted to bring up. I know we're out of time, but I just wanted to see what people thought about tackling those problems, because I am one of those people who is actively using multiple data sets at the same time.
I'll make a couple quick comments. Thanks for raising all of those. First of all, I consider it part of my job as a person who is associated with the facility to answer those questions. If I am not doing that, I am not doing my job. Full stop for me. So you're doing the right thing by discussing it with people. And these are complicated techniques. They are not straightforward. So the more things you have to use, it's just going to take more time to work it all out. I think that's part of the scientific process. For the journals, any journal people in the room, like associate editors or that kind of thing, these should be communicated back up to the journals themselves, is that restrictions like that one, if they start getting in the way of doing the acknowledgements, it's just, that's not a good situation, and we need to change it. You know, it's revolving around the open science and the acknowledgement kind of area too, which is still a work in progress, and we don't really know how to do it completely well. But I think that message needs to get back to the journals pretty strongly too. And there are journal editors floating around this meeting, and it would be very good to make sure that we can communicate that back. So,
I'll
anybody
add
else
one
wanna?
more point to that.
Yeah.
So yes, it's part of our jobs to communicate to you. Often we have students who are also, you know, good at looking at the data, and it's a great opportunity to bring those students in. Maybe they could provide value. They understand the data. Another fact that happens to me a lot, embarrassed to say it, but when I interact with people who are publishing things, I find a problem in our stuff, not in your stuff. And so it speaks to me, I'm like, okay, there's a hole in our validation, that should not have gone out. Let me go fix that. So that type of engagement with the scientific community is actually, it's very valuable to me to make sure that it's basically like a scientist in the loop on our validation and verification procedures. So I would just add that I actually look forward to it. It scares me sometimes when I have to go back and look at the processing, but I very much appreciate that.
Yeah, and in a way of selling our products, if I get a question about one of the images we have, one particular event, I try to answer pretty quickly, because that means that you are giving a quick feedback and allows that customer, in quotes, to come back to you for more events. So I don't, like Phil and Emma, don't wait there, oh, I had to answer, because we are really eager to get the data out, and we don't have the time to go through all our data. So if other users are looking at the data, we're happy.
I will also say, because a lot of our data providers know each other, all right, ask one of us a question, and we will literally hand it off and around until we find the right person. It's just, don't be afraid to start that conversation. It is better for you and better for us, for sure, and for all the reasons that just got talked about. It's a community, and we need to share that and help you.
I'm happy we are ending the panel in a very happy note. So I want to thank all of you for all the discussions that we have had, and everyone in this room. Thank you so much for attending this panel, and this is going to be an ongoing conversation. So thank you, everyone. Thank you so much to you. And Bob Robinson. Thank you, guys.